Welcome back to this time chapter 7, and chapter 7 will be quite a bit specific. In other words, we'll be dealing with PCG framework where we're going to implement PCG graph to build structures. In other words, we are going to have a very interesting exercise to not only get into, but at the same time working on finding ways to create a sort of like architectural buildings. I wouldn't say we're going to create a super cool looking architecture, but what we're going to do is actually going to use the principles that will help to build a foundation for later in any projects you're working with. That will be very essential, but also helpful to build environments based on the buildings. So in other words, what we're going to do is to create a cool foundation of the PCG framework, where it will help you to not only define the sides of the walls, but at the same time we can use this to build each level as we go upwards, the heights as well of the building. And because this exercise already has a PCG blueprint prepared for this, to cut in other words, to make a shortcut to build this exercise, so we don't have to worry about going through the technical side of things. We can use this to basically build a structure, and in this case, this blueprint, what it helps with is to create a space where avoids some of these, in this case, meshes to be spawned. So it leaves the gap in between the meshes that are generated, but also leaves a gap for things like, for example, windows and so on. What I'm going to do now, I'm going to start working on the main blueprint, which I'm going to first start off with creating blueprints actor for that. So let me go right click inside the blueprint, create actor. Let's call it BP underscore building structure. And just to let you guys know that because this exercise is going to be a very, I wouldn't say complicated, but more of a time consuming. So what we'll do in this case, we are going to break into parts. So we're going to first carry on the first part of the video, and on the second part, we will finish this entire exercise, which means that we'll use 2 videos for that. So let's open this up. And let's start adding the components we need. So let's start add spline. And as always, we're going to use PCG component. So what we're going to do, and that is very important because we are actually going to create a spline, not just like we did before, where we can just drag and literally duplicate these set points for each spline points. What are we going to do? In this case, we are going to use one of the tools, which is spline generation tool. And to do this is just basically, in this case, what I'm going to do is first to remove this point, because what I was going to do is going to overlap, and it will be like a little point sticking out of there of the existing newly generated loop. So I'm going to just remove this and right click, and I'm going to use the spline generation panel. And what it does is you can set up to whatever you want it. So in this case, we're going to use a square. And the reason why we use a square is because it's going to be a building. So I'm going to just extend it slightly so it can make it bigger and leave the anchor where it is. Let me just make it a little bit bigger, maybe like this. That should be enough to start working with it. And let me check the dimensions, how they are in, and I think we're okay. And make sure we also close the loop. And also what you can actually do in this case, because there's this little loop that has literally entangled around right at the beginning. And to do this, what you can actually do is also you can remove that section here. So you can just press on that pointer there and just hit delete key button to remove that. So now you should be able to just have it a very cool rectangular shape loop. So I'm going to compile that. And next thing what we're going to do is add variables. And so let me just start adding those. First, we're going to call dimension offset, set it to float. And next one, we're going to call number of floors. In this case, it's going to be integer. And I'm going to make them public Make sure you always, let's compile this and make sure you always set this to the right values. We don't want to have any crashes later. Set the number of floors to 1, compile that. And to begin with, we're gonna go actually work on our actor blueprint here first. So I'm going to start adding a few of the necessary functions to work with. So in this case, what I'm gonna do is I'm going to create like very helpful little mathematical formula here that you can always reuse it many times when we're gonna go through this exercise. So in this case, what I'm going to do is to first drag into, get our dimension offset here, drag it in, and I'm gonna build up the numerical operators here right now. So I'm gonna right click and look for divide operator, and at the same time I'm gonna look for multiply. And what we're gonna do is to plug this into the first one, and I'm going to then also plug it here and set this to -1. So we're gonna have that conversion there for us to set it to different direction. I'm gonna duplicate by 2. And the reason why we do this because later on we're gonna work for the exercise, and when we do this little mathematical formula here is to make sure it works perfectly fine with the walls that being divided and spread across the along the spline itself. So that's why we're doing this, is to reduce the number of overlapping walls, because the walls, if I show you as an example, and the assets we're gonna use for this exercise, we're gonna use the cube. And as you may see, the walls itself has its offset being pointed right in the middle. And the reason why we're creating this little offset formula here is to make sure that it doesn't really being spawned right in the middle. It can be basically based on the positions that have been applied, and between the point center of this cube to the edge of the cube will be sort of split in 2, which means every time it gets spawned, it spawns properly where it should fit. So for example, the next cube, instead of overlapping like this, it will be basically based right in the next next to another cube. And that's the whole point of doing this little formula, to reduce such complexity while spawning the, in this case, walls, but at the same time is to make sure that we don't have any problems when we try and work this in the PCG framework itself. So that's why we actually going to implement that formula for. And in this case, what I'm going to do, continue with that. And I'm going to select all of it, and I'm going to collapse this to macro. In this case, what I'm going to call this is I'm going to call it offsetter. Let's open this up, and I'm going to connect all these nodes inside it. So just to make sure we can a little bit bigger, we can now remove this dimensional because we don't need it anymore. And basically what we do, we are going to use this input, and we're going to actually assign this as our dimension offset. So in this case, I'm going to call it offset and turn it to float. And the next one, I'm going to connect this to A. And in here, I'm going to create 2 outputs. And one will be offset position. And next one will be reverse direction. And that's how we're going to use this to work with our example. As you may see, we have created a macro function. Because we already created a macro function, we can just remove it for now. Then because we always have it available here on our graph and under macros. And we can compile it. And the next bit is to go back and start working on our PCG graph. So I'm going to go back and I'm going to create a PCG graph here. It's going to be PCG building structure. And also, let's just quickly assign this so we don't forget. I'm going to assign this here. Building structure, compile it. Let's go back to our building structure graph, and let's start adding the nodes we need. So in this case, first to start off, we're going to add 3 nodes. Get spline data, spline sampler, as well as get actor property. To start off, let's use the spline sampler here, and let's change the dimension to an interior. And for now, let's unset to unbound. And here, I am going to, of course, name it as we had it here, and in this case, going to be dimension offset. And let's go connect them all together. I'm going to connect this to spline sample, get spline data. And then what we do usually, in this case, I'm going to connect into interior sample spacing. The next part is to identify the structure by setting up for directions of the spawning, in this case, points, which will basically change depending on which direction they are facing. They'll be pointing across the spline sampler itself. So that means the boxes, in this case walls, later will be spawned in any direction that we set up condition by using transform points. And at the same time, this will be useful to build up this entire wall structures that will basically spawn all the static meshes across the spline sampler itself. In this case, will be along the spline itself. So that's the point of this exercise, to use this as like sort of like a foundation to create the directions where the cubes will be spawned as we set up the conditions here. So in this case, what I'm going to do is right click and look for transfer points, and I'm going to duplicate it 3 times. I'm going to place them properly so that at least they are sort of aligned in a much more best manner as we can. I'm going to connect them all together for now. And what we're going to do is to create 4 difference nodes. In this case, we're going to use for 4 walls. So in this case, we're going to use this as a source, and I'm going to use this as a difference. So every time there's a source of info of the points being generated, that will feed in. And then every time we want to make a difference with the new wall that's going to be generated, it will basically be removed from that transfer points. So it's very interesting. So the points are being generated as go along the spline, but if we want to create a new wall for the next coming wall, which comes from different direction, they needs to be also removed to give a pathway to the other wall. So I'm going to do the same thing here. So this will be pretty much how it should be connected. And we got to do the same for the other walls too. And that's pretty much what you should be having. Now it's good to set up the rotational direction for each of the walls going to be spawned. So in this case, I'm going to set my minimum and maximum rotation. So in this case, we're going to start with -90. Let's set -90 as well here. And next one will be +90. This one stays at 0, so we need to set up the center position. And at the same time, I'm going to set this to 180. So it rotates on the opposite direction. Let me compile this. And to test this out, what I'm going to do is to now go and debug this. So let me just click on debug here and compile that. And as you see, if I drag and drop into our scene, then we should start getting some cubes generated across the field here. So that's good. Of course, we haven't done yet the most important bit, which means the walls that are being only generated along this spline and removing the ones in the middle, but this is something we're going to do next. So as you can see, as you drag in more and more, it creates this very cool effect. And that's cool. And at least we got the principles working. So let's go back and let's go set up the variables that will be working with the walls here. So let's go to graph settings, and I'm going to add 4 variables. And they're all going to be vectors. So make sure you set them to vectors. And I am going to first rename them. And the way we're going to rename them is going to be pretty much straightforward. So I'm going to press F2, or you can just basically go click on rename and call wall west here. This will be wall east, and this will be a wall north, and this will be wall south. It should be much. And next thing is I'm going to add the variables here. So let's go wall west. I do it just like it is on the graph menu over there. Let me just make them bigger. in terms of spacing here. And I'm going to set these to offset minimum and maximum. So let me just show that. Yes, offset max and minimum. Let's do the same thing here. So this will be our wall east. For the offset minimum and max, so it's connecting them both together. And let me just do the same thing for that one, which will be our north. And at the same time, I'm going to do the same thing for transfer points on the bottom, which is the south one. With all this add up, we can then merge them all together into this one, in this case, stream of nodes. So what I'm going to do is right click. I'm going to look for merge points and let me go connect them all together. But a good thing to also notice that you can also just drag and drop into this, and that will create a 2-point sub node. But what you can also do is to right click and search for 2-point, because that's pretty much the same thing. What it does is converts the points configuration here to spatial points. So I'm gonna basically, you can use that too. What you can do then, connect this all together just like that into one node. And I'm gonna basically place them into the right order. So that should be pretty much how it should be at the moment. And now what I'm gonna do is to go back and then obviously set up our transfer points once more. So I'm gonna right click and look for transfer points. And I'm going to connect it all together to sort of normalize it. In other words, to set all the directions properly. And that's pretty much it. We can go debug it once more. Of course, nothing's going to work at the moment because nothing has been set for our walls here in this case. So I'm going to leave it as it is. And I'm going to go back to our, in this case, blueprint actor for the building structure. And let's start adding some of the functionalities here. So first things first, I'm going to use our PCG that we have, component, drag and drop into this, and let's start adding the graph instances. So in this case, I'm going to get graph instance. And what we have already created in our PCG here, graph, we can reinitialize it and put it right here inside our PCG blueprint. So I'm going to drag it out and look for set vector parameter. I'm going to duplicate 3 times. I'm going to connect all together to graph instance. And let me call them just how they should be inside. We have it here. So it's wall west, east, and so on. So I'm going to call wall west. So make sure the naming convention is the same as the one we have already declared in our graph settings in the parameters section. So it should be wall west, east, and north and south. And you have to replicate here because you literally, in this case, accessing the graph instance that comes from the graph component here. And then you need to get those namings right if you want those PCG components inside the graph itself work together with the PCG blueprint here. So and also what's so good about it, and we're not going to use, because as you may notice, the values are reading at vector, but we can also only use, in this case, floats, because we only need few of the axes to build the structure of the walls. So what I'm going to do is right click and spin to struct pin. To repeat the same for the other nodes here. So this is a crucial part because this is where you have to pay lots of attention to certain details. And the reason why, because we need to make sure we properly plug into the right, in this case, input values here to make sure it works with our, in this case, the vectors that we're going to build the walls up onto it, their directions. So this case, what we need to make sure is, because we're going to rely on the offsetter that we have created, The way it literally works is that we are going to use offset position for each of the values, depending which walls we're going to use for that. And then we're going to use a reverse direction to do the opposite. So in other words, we're going to have the facing the one direction and the other walls will be facing the other direction. That's why we have offset position, which should be kind of like one direction and the other will be reverse direction. But anyway, the point of this is to make sure that we have something to work with. But first, we're going to start off with the first two walls here. So I'm going to first put this to one direction, which is going to be X value. And I'm going to then use this, the reverse direction, which is going to be the other value, which is going to work on the X direction value. So, and I'll do the same thing for first offset position, which is going to be, in this case, working for the wall of north. And the reverse direction will be our south wall. So I'm going to be at Y. So I'm going to have this ready. And first I'm going to actually get this connected together just like it is. Let me compile it and let's connect it one more and compile again. And next thing I want to do is then bring my dimension offset parameter, a value right here. And then I'm going to connect it into the offsetter altogether. Let's go back to our building structures PCG graph. I'm going to use this to debug it. And technically, yes, there we go. We should start getting some walls. And that's pretty much what we get. Actually, we're gonna now, and let's go back to our PCG graph, and actually we can do now disable debug, and we can add our static mesh spawner. And in this case, what we'll do is add one mesh entries. So in this case, we're gonna use wall cube. So I'm gonna look for a wall cube. There we go. And then let me plug this in and let's test this out. And now you start seeing our wall start to form, which is great. This is what actually we needed to have to take its shape. But what you may notice, the corners around each edges are being sort of removed. And that's the reason why, because we haven't properly set the pivot positions to make sure that it kind of fits in the spline, because it literally generates another set of cubes along the spline, ignoring the one in the corner. So to fix this, what we need to do is to go to our graph settings and add another parameter. This will be also our vector, just like we did it previously. We're going to call this time fixing the pivot. And I'm going to have to set this to 1. So right click and then look for it here. And I'm going to use this, our transfer points, and reset this to work with our fixing pivot, offset minimum and maximum. And we need to also add this to our inside actor blueprint. So let's go back. I can go copy this one. And we can so basically remove this and use the fixing pivot. And I'm going to also plug this into our graph instance, just like we did it before. And also what I'm going to do is use our offsetter like we have created before. So I'm going to connect this together with the X value because we need to fix the X value. But in this case, and I'm going to use the reverse direction and set it to X value. And I'm going to also add this dimension offset, click or add it here. I'm going to connect it all together. And our corners got thick. So that's why we needed this particular little installment to our existing graph structure by having this a little fixer that kind of fixes the issue, particularly for this problem here. So that's why I wanted to go through this all together. I think for now we can leave it as it is, and I think we can go and close this as the ending of our first part of this chapter 7 tutorial. And the next part what we're going to do is to create not only the much more advanced wall structures by having this another set of parameters that will help us to create the openings for windows or doors and so on, using that blueprint that I've prepared for this exercise. But at the same time, we also going to create upright positions for the floors to take place. In other words, we're going to create extra nodes that will help us to create floors numbering by adding extra floors, including those walls that are being generated. So this is something we're going to look into in the next part of that chapter 7. For now, thank you so much, and see you in the next part.